Welcome back to the garage. This week's video we're just going to be stripping apart the clutch cover, and then we start tackling the upper part of the crankcases. Plus I've decided to have a go at powder coating. I just got to extract the water pump bearing, which is a blind hole, so you need a bearing extractor, which is one of these expandable things. I didn't have a M10 one, so I just made one up out of some steel, and it just works by the pin. I got a eBay set, which was okay, but limited size, and the metal wasn't very good and they tended to break. Anyway, I made up a new one of these, and all you do, as it winds on, that fans out the ends. You can see it sort of expands out and it just grips on the bottom of the bearing, and then you can use a slide hammer to bring it out. Anyway, hopefully this will work. Of course, you can hold this down. I'll just get a clamp on that. Stubborn. Whoa! Once it goes, it goes. Yeah, so it's come out okay, and that's the important bit we need to get at, is the seal needs to be definitely replaced. It's quite a job actually. I think you know if you've got a leaking seal is your gearbox oil turns into sort of like a browny cup of tea, even white emulsion. Looks like it's got milk in it, and vice versa. If it's leaking the other way, you've got oil in the water, you can tell because it turns into sludge. Obviously we've got to replace the two-stroke oil pump seal as well, but hopefully that should just pop out with a screwdriver. The next step is to see if that just pops out, drifting it the other way. So we'll just see if we can push that out. You could use a socket for this. So this is M16. Just tap that out, hopefully with a soft. I need to buy a copper mallet, but I've only got this rubbery thing. Anyway, you don't want to use a steel one because you just chip your nice sockets. So hopefully that will just tap out, he says. Mind your fingers. So that's the seal. In case you're putting one in, the sort of, how do you describe it, the nice end with the numbering on it faces the water, and the open end faces the gearbox. So that's that one done, and the last one is this seal here, which I'm hoping is just going to be a screwdriver job. Screwdriver, here we go. See how easy it is to pop it out. If you don't, yeah, it's very easy. I think it's a bit too easy. Again, the smooth edge faces out, and the open end faces in. I'll say open end, the grooved section here. But this is a 10/22/7. So 10 is the inside diameter, 22 is the outside diameter, and 7 is the width. In case you want to get one from a bearing shop. And then for this one, okay, it's quite a mouthful, but it actually says water side on the inside, so yeah, it helps you put it in the right way. The number though is FLJ7-10-31, and then it's -13.5-3 if you need to look that up. Anyway, I recommend just getting genuine Yamaha bits. Seals are cheap in the scheme of things. So now that's completely free. You could, that's a push fit bush, and it's a part you can actually still get, I think. I'm not going to bother pushing that out. I think it's fine. There's no like excessive wear that I can tell. So that's the oil pump worm drive, and I think it goes, yeah, that way. And that's a pretty good fit. There's no movement on that I can feel. Yeah, and looking inside with a light torch, there's no like wear marks or score marks. So I think that's fine, and obviously the seal does its job keeping most of the stuff out. I think obviously this gets lubricated with two-stroke oil because this is a dry cavity. You know, the gearbox oil doesn't keep this lubricated. The two-stroke oil itself does, quite clever. And obviously the seal, paper seal, keeps it from running out. So the oil completely fills this area and goes down in there as far as the seal but stops. So yeah, but if that was really wobbly and gouged out, you could push that out and buy a new one. Now all I've got to do is clean it up and paint it. Just as a side note, I'm thinking about powder coating the cases. I bought an oven, etc., and I'm going to do a bit of tests, some tests on some scrap, see what it looks like. But and I'm a bit worried maybe the powder coating might be a bit thick. So I don't know. We'll what the heck? We'll powder coat them and see what it comes up like. So I've just picked up a free oven that was on Facebook Marketplace about a week ago, a couple of weeks ago actually, and everything seemed to work, but I found that the bottom element, this thing, had obviously broken in its lifetime. So I bought one on eBay for $50 I think it was, and yeah, it's working well now. We see it glowing red hot in there. So yeah, it's getting up to temperature. It takes about 10 minutes. And we're about 150 at the moment. Supposedly it goes all the way up to 280. I think 250 is the sweet spot for powder coating. I don't know, but yeah. So now I've got to put it on the floor. Probably stick it underneath the bench here because it doesn't get hot at all. Only the bottom is probably the hottest part. Down the bottom, that's probably the hottest. Yeah, it's just too hot to touch at the moment. So I'll stand it off on some steel feet and just put it on the concrete floor. Yeah, so the oven takes a 15 amp rated plug. So in Australia, the normal plug have a earth which is smaller than that. You can see on here on the left, that's the earth pin, and it's the standard size. On the 15 amp ones, this is slightly taller. So this, I'll put this in actually because I thought I might get a TIG welder one day, and I thought maybe I can get the more powerful one or bigger amperage. So yeah, just be mindful if you are buying an oven, you can't necessarily just plug it into any old mains socket. You need to just check with an electrician or something. So I'm just removing the studs, which are notoriously difficult because the aluminium and the steel bolts, plus there's obviously radiator fluid running around these, close by these. And yeah, so I tried the two nut method, you know, like locking two nuts together, but that wasn't going to count. So I ended up buying this stud remover, which is actually it's very big and chunky. I might actually make a slimmer one, but it's proving quite good. I've managed to get out most of them so far without shearing them. These two at the back though are problematic, so I'm coming back to those shortly. But yeah, it works quite well. What I do is I put the hammer drill on this a few seconds to sort of hopefully shock it to move, and then I put a T-bar, a wrench on this, and it does undo eventually. Yeah, so you can see there's a lot of corrosion on that one. I'm going to make up new studs because they're pretty stuffed anyway before I put this on this. Yeah, so that seems to work. So I ended up putting a bit of heat just on this one. Not too much, not glowing red, but enough to sort of be hot to the fingers. And that seemed to make a big difference. It started to move a lot easier. So I think we're getting there. Stubborn one. That was a hard one. I think this is going to shear. Yep, I think it's shearing. It's always one. You bugger. Worst case scenario. Ugh, that is a pain because we've got half the bolt still down the thread. It would have been better if just to shear off at the top. Oh well, in for a penny, in for a pound, I'll say. Stud extractors. So you can see down in the bottom there, that's the sheared off bit. It's probably where the thread obviously is seized, because we've got obviously these are a dowel that locates the barrel onto the casing, onto the crankcases, and so obviously that goes down partially and then the thread starts. So what I'm going to do, these have got to come out anyway because they're pretty beaten up and rusty. So I'll make up some new ones because they're nothing particularly special, they're just a bit of steel. But what I'll do is I'll yank these out now because that'll have to come out before I start doing the extraction job. So I'll just quickly measure what these are. So these are probably, yeah, a fraction under 10 mil. So the barrel slips on okay. And height wise, just over 5 mil. The ID is just over 8 mil, 8.25 probably. Yeah, so I'm going to collapse them so they hopefully will extract. That's another difficult job. We need 4. All the same height, I think. Yeah, just over 5 mil. And they've got a slight, if you are making them, they've got a slight, yeah, they've got a slight taper at the top just so the barrels locate smoothly on them. Nothing, again, nothing special. Okay, so we'll try and yank them out. One out. So just crimp them up so they collapse. And then you've got enough purchase, hopefully they'll come out. There's one. 2. This one's not so friendly. That was a bit stubborn. What it is, I've got a punch just a bit smaller than the diameter of the dowel. So when I crush it against the dowel and it gives you a bit, I crush it against the dowel and it gives a bit more purchase, and then you can just twist it and it will eventually come out. Okay, last one. After a bit of wiggling, that one come out. So it's a bit medieval, but it works. So yeah, got to make 4 of those up. Getting that broken stud out, and the really hard bit is because the uneven surface, it's hard to get a centre and then a drill in there, but we'll do our best. I did actually go out and buy a set of extractors before I needed them, because the idea being that if I bought these I wouldn't need them. It nearly worked, only one failed, but yeah, so these are quite handy because and obviously I think these are M8s. So M8, well, we can either try a number 2 or number 3. I think we'll start off with number 2, see if that works, and then open it up. So this is a 10 diameter hole because of the dowel. So to help us get a center punch sort of in the middle of the stud that's we've got to remove, I've got a 9.5 drill which just about fits in there, and just gently make a mark in the middle. Then we can put our center punch on that. Then we get our little drill set. And open the thing. How the hell? Safety thing. Blimey. Certainly make it adult proof. Hey, got in. So, number 2, these 2. As it say, mark the centre of the broken screw or bolt with a centre punch. Drill hole deep enough to allow extractor to engage with bolt. Insert the extractor into hole. Oh, use some cotton fluid. Now, if you're buying extractors, I would recommend getting ones with left-handed drills. When I bought these, I assumed they were left-handed, but when I looked at the packaging again, they're normal right-handed. The left-handed are better because it starts drilling and can actually cause the stud or bolt that you're trying to remove. It'll actually unwind it because the left-handed drills they go anti-clockwise. But these are normal drills. Obviously the hole's quite deep. That's not going to be a problem. Yeah, because you don't want to keep drilling all the way. Put a hole in the casting. Now the fun bit. So this goes in there. Now I don't know what's best here, to use a ratchet or just a tap holder. Yeah, it says use a tap wrench. The thing is, I just don't know if that hole is weakened it enough. Otherwise he's going to snap this off. Yeah, don't like it. Because to be honest, that won't have made much of a difference. I think what I'm going to do is drill it out to almost M8 and see if we can collapse it that way. Bit more, I think. How am I going to do this? I think I might make up a guide for the drill so it's on center. Otherwise we're going to wander off and start drilling down the thread. I mean, it might be that we have to put in a helicoil. We're going to have to put a helicoil in, so new thread. That's a possibility. I mean, the load on these is very minimal. It's only not the torque on it is very low. I'll machine up a guide for a 7.5mm drill and see if we can open that up. I don't think these extractors will work because that's obviously corroded and stuck in there fast. So the plan is to try and drill out that hole to just under the tapping size, which is 6.8. So what I've done is I've got a 6.5 drill and just made up like a sleeve that's the same size, and that reduced the shank is just a snug fit on the dowels go, and that way it's going to help me drill on center and also keep it parallel to the axis of the tap, hopefully. So that's 6.5, and then I made up it's actually a proper drill for 8mm, so it's 6.8, same thing, snug fit. So I'll eke it out with 6.5. The problem is getting that last little bit out that's stuck in the thread because it's corroded. So it's a catch-22 here. You'll have such a little bit left that you may not have enough purchase to snap that out. Yeah, so this is going to be interesting. I'll probably end up, unfortunately, having to helicoil it, which I don't want to do, but I think we'll just get on with it. So we'll see how we go. Oh, look at that. That's not a helicoil, that's what's left of the old thread. So we may have got away with it. Just. Let's give it a clean out. Looks like there's a bit of the thread still in there. I think that's the last bit. Tiny little bit left, but I think we might just be able to hook that out. The thread looks reasonable. We'll run a tap down it just to be doubly certain. Yeah, thread looks all right. I think we're good. Yeah, it feels quite good. Certainly not loose. I think we're lucky. Yeah, so that thread looks all right to me, and the way it was screwing in, it's not like waving around in the wind at all. This is one of the original studs, just to see it goes in okay. I think we're good. Nice and solid, it's not going anywhere. I made a quick sketch of the cylinder studs. There's 3 different lengths, so bear in mind when you reassemble, you make sure you put the right stud in the right hole. You can cross-check the parts diagram, that will help you to know which one goes where. So now I'm just going to remove the crankcase studs, the main ones. I've just dropped a bit of aluminium on the faces of the crankcase, just so you don't damage it when you're trying to remove the studs. Before taking these studs out, as I did on the other ones, before you take them out, remember to measure them, how far they're sticking out. There's 3 different sizes, 73mm, 83mm and 103. So just make a little map of the studs, and just record their lengths so you can put them back in exactly the same, because they'll line up with the lower casing. So I'm going to try and push out the engine rubber mounts front and rear, which is going to be interesting. Just to try and support the casing so it doesn't tip when I'm obviously pushing it through. I've just made a little cutout that just supports the casting around the edge a bit. Then I've just machined up this, which I've made the depth the same height as how far the inner part of the bush is sticking out, so hopefully it applies pressure to the inner bit, which is rubberized or connected to the rubber, and the outer ring, so they push consistently. But the problem is you're going to be pushing through on this, which is rubberized, so I don't know if it's going to work. There's going to be too much bounce. We'll try. Feels like it's moving. Just check why it went bang. I think it's just pushed out the rubber bit, the grommet bit. Anyway, we'll keep going. Okay. Oh, maybe it did. Oh, well, it did work. Okay. I thought it had pushed it out. You know, pushed the inner tube would push all the way through. Now the question is, can that come out this side? Oh, it does. That's good. I mean, these might have been okay, but it's like I say, this bike's getting on a bit in age, and all these rubbery bits can start to fatigue, and they're not too expensive from memory. Yeah, so they're the front two. Okay, I got the right space here, so we stop the whole thing from leaning over, and we don't want to load up the casting along this edge, so most of the force you want through this little aluminium tube. So hopefully it was as easy as the front one. See how it's deforming the rubber down there? It's going to go ping. There, starts to. So I think that rubber is the problem. It gets so far and then it will just overcome the friction, and the outer sleeve slips. That's where you get that bang. Anyway, it's moving now. You shouldn't really stop. Once it gets going, you shouldn't stop the press. Oh, I'm just hitting the top here, so I've got to stop. Ooh. Yeah. Damage that. Slightly longer spacer. There she goes. Clang and a bang. It's going to be a hard one to get out. That's the bottom one, slightly stubbier. So that might mean we have to push this out. Is that right? Don't think it want to come out. Yeah, we're going to have to push this one through all the way, I think. Finally. So the front two. Rear two. Slightly shorter. Cool. If this bearing comes out quite easily, I'm probably going to reuse it. It's the clutch lever mechanism bearing. So, I mean, I could leave it in there, cover it up, and then sandblast it, but I'm always worried that you're going to get a bit of grit in there, and we don't want grit in the engine. So hopefully this will just slide out really easily, he says. It's not going to come. Yeah. So I've just warmed that up, and it's now able to push out the bearing. I'm going to have to put the camera down because I'm going to have to catch everything as it falls out. Hang on. You saw earlier I tried to do the sledgehammer, but it wasn't budging, so what I did was like that, and then I left the expandable extractor in like that, and then I was pushing from above. Also I put a fair bit of heat on here just to let everything expand with a bit of pressure on it, and it moved quite easily. So I'll have a look at the condition of this bearing and see if it's retrievable, because it doesn't look half bad, and it's not exactly doing much. It's just obviously rotating 90 degrees. So I think I'll give it a good clean in the ultrasonic cleaner, and we'll reuse it. But the main thing is to get it out, because you know you don't want grit when you, and also it's got to go in the oven to hopefully powder coat it. Last job is just to push out this breather plug, which will just be a drift, I think, down in there, which hopefully doesn't need much of a whack. No, it doesn't. But that's out again. You can reuse this. That's fine. I think we're good. Everything is now. Oh, the last thing is this dowel, locating dowel. I don't think I'm going to remove it. It's fine. It can stay there. Just give it a good clean. It's not rusted out, which is good. It's still quite shiny. So, and this could come out. This Kickstarter retaining pin. But I'm not going to bother. I'll just tape it up when we powder coat it. Yeah, it's a long old job to fully strip that. I wouldn't advise it. So that's it for this week. The next video will go into the first attempt at powder coating the cases. So I'll give them a quick blast with glass beads to bring them up to a good finish. See you next time.